Hello everyone, welcome back to my channel Binary Hath. We have been hearing a lot about different LLMs like GPT-4, BERT, T5, Gemini, Wayne, and many more. GPT-4, known for its advanced capabilities and versatility in various tasks, BERT excel in understanding context and bidirectional processing. T5, designed for text-to-text tasks and multilingual applications. We know they are all large language models, but are they all built the same way? Let's find out. They aren't all the same. The architectural design of LLM is a huge factor in what it can do. The design determines how the models processes data, which in turns dictate its capabilities and limitations. Think of it like different types of engines for different kind of vehicles. Capabilities and limitations influence models' performance and applications. Architectural design determines what processing methods data processing dictates models' capabilities and limitations. So, what is the main engine for today's models? The most dominant architecture by far is transformer. It was introduced in 2017 research paper called Attention All You Need, and it really revolutionized the field. Before transformers, models like recurrent neural networks RNNs and convolutional neural networks CNNs were more common for language tasks. RNN previous models used for language tasks like natural language processing, machine translation, speech recognition, and time series forecasting. CNN, another common model, optimized for data with a grid like structure, highly effective for image classification, object detection, facial recognition, and medical image analysis. Why was the transformer so revolutionary? Its key innovation is something called the self-attention mechanism. This allows the model to weigh the importance of different words in a sentence, no matter how far apart they are. This solved a big issue with older models like RNNs, which struggled with long-term dependencies in text. Plus, transformers can process inputs in parallel, which makes training them on massive datasets much more efficient. Self-attention mechanisms, parallel processing, process inputs simultaneously, efficient training trains on large datasets, improved performance enhances models' accuracy. So the question is, are all transformer models the same? Not quite. The transformer architecture is typically implemented in three main configurations. Okay, so what are they? Encoder only, decoder only, encoder decoder, transformer architecture. First, you have decoder only, also called casual transformers. This is the most common architecture for big generative LLMs. You hear about like the GPT series and Llama. They use only the decoder part of the transformer and work by predicting the text word based on the words that came before it. It's essentially a very sophisticated form of autocomplete. This makes them excellent for chatbots, story writing, and code generation. Well, that makes sense for something like ChatGPT. The second is the encoder only architecture, sometimes called as masked transformers. It uses only the encoder stack and is designed to understand text, not generate it. It learns deep bidirectional representations, meaning it looks at the entire sentence at once to understand the full context of every word. The classic example is Google's BERT. Because of this deep understanding, they are great for tasks like classification, sentiment analysis, and information retrieval. So, decoder only generates text and encoder only understand it. What's the third one? Third is the encoder-decoder architecture, which combines both stacks. The encoder's job is to understand the input sequence, and the decoder's job is to generate a different output sequence based on that understanding. A great way to think of it is reading a paragraph in English, the encoder job, and then writing its meaning in French, the decoder's job. That makes it perfect for machine translation, summarization, and question answering. T5 is a well-known model that uses this design, and that clarifies the main transformer types. But we also heard about models like Mistral and ChatGPT 4. Do they fit into these categories? They are based on transformer principles, but they have additional specializations. Mistral, for instance, uses a mixture of expert MOE architecture. This design uses the multiple expert subnetworks, but only activates a few of them for any given input. It's a clever way to scale models to a massive size while saving on computing costs during training. And GPT-4 points to its being a multi-model architecture. These models extend the base LLMs to handle more than just text. They can process vision, audio, or other data types. So you can show it a picture of chart and ask what it means, which is a classic use case. Gemini is another example of multimodal model. I hope this is a lot clear now. The architecture really is tailored to the task. One last thing, we have seen the term RAG mentioned. So, what is that? RAG stands for Retrieval Augmented Models. This is another design where the LLM is connected to an external knowledge retrieval, like a vector database or a search engine. The purpose is to overcome the limitations of the model's training data and reduce hallucination. So, if the model does not know something, it can look it up before answering. It's especially useful for building chatbots that need to answer questions based on specific company documents or other up to date information. So it is not just one type of model, but a whole toolkit of different architectures for different jobs. It's a fast moving field, but understanding these core architectural designs gives you a solid foundation. Thank you for watching my video. Please subscribe and press the like button.